Welcome back to our Math 171 video series. In this video, we'll go over how to solve a system that has three variables. Here we have a system of three equations. You'll notice these three equations have the letters x, y, and z in them. In order to begin solving this system, let's pick a letter that is easy to solve for, and preferably by itself. You may notice in line 1 we do have a y that has no numbers and no other signs next to it, so let's begin by solving for that. So in line 1 we will begin with 5x plus y minus 4z is equal to negative 4. The y is by itself here, so let's try to move everything else to the other side. We'll take the 5x and the minus 4z and move them both. When we move the 5x, it will become negative 5x. When we move the minus 4z, it becomes positive 4z. Now on the left we have only y is equal to negative 4 minus 5x plus 4z. Now that we have an expression for y, we will replace that y in the other two lines in the equation. So we will go to line 2 and line 3 and replace every y we see with this new y expression. We'll begin with line 2. Line 2 says negative 3y minus 6z equals negative 21. We replace that y with that new expression. We do the same thing now with line 3. Line 3 says negative x minus y minus z equals negative 6. And again, we replace the y with that expression. Now we'll go to the next page and try to simplify. We'll now begin by simplifying line 2. We'll begin by taking negative 3 times each of the terms in the parentheses and distribute them. When we distribute, negative 3 times negative 4 gives positive 12, negative 3 times negative 5x gives positive 15x, and negative 3 times positive 4z gives negative 12z, and then minus 6z equals negative 21. Now we'll combine any terms that we can. We combine the negative 12z and the negative 6z, and this will give us negative 18z. Now recall that we want letters on the left and constants on the right. We do have a constant that's still on the left, and so that constant is going to have to move. This 12 will need to move to the other side, and when we move it, it becomes negative 12. After the move, we'll end up with 15x minus 18z equals negative 33. This will be our new line 2. We'll do the same operations on line 3. We'll take the negative sign out in front of this parentheses and multiply it times each of the terms inside, and we'll distribute again. We'll still have a negative x in front. Negative of negative 4 gives positive 4. Negative of negative 5x gives positive 5x. And negative of 4z gives minus 4z. Still an extra minus z equals negative 6. Now we'll combine any terms that we can. We have a negative x and a positive 5x. This will give us positive 4x. We also have a negative 4z and an additional negative z. Together this makes negative 5z. We also have this extra plus 4 equals negative 6. We'll also need to move this constant, positive 4, from the left to the right because we want our constants on the right. We will have to move it to the other side. When it moves, it will become negative 4. Therefore, our new line 3 will be 4x minus 5z is equal to negative 10. With these two new lines, we now have a system of two equations, which we can solve using a two-equation method. We'll do that on the next page. Now that we are down to two equations, we'll try to pick a letter to eliminate. Neither one of the letters will be very easy to eliminate here, so what I'm going to do is select x arbitrarily and think about how we could make it eliminate. we can see that the numbers in front of x are 15 and 4. Since those numbers will not eliminate very nicely, what we'll do is multiply line 1 by 4, that's the other number, and multiply line 2 by 15. Also, since we want the x's to eliminate, we'll have to make one of those numbers, the 4 or the 15, negative. So we will write times 4 on the first line and times 15 on the second line. It doesn't really matter which of these two numbers is negative, so I'm going to make it the second number just randomly. If we multiply the top equation by the 4, 15x times 4 will give us 60x. Minus 18z times 4 will give us minus 72z. And then negative 33 times 4 will give us negative 132. In the second line, we'll take negative 15 times 4x for negative 60x, negative 15 times negative 5z for 75z, and then negative 10 times negative 15 for 150. If we combine these together, the 60x and the minus 60x will cancel out. 75z minus 72z gives us 3z. 150 minus 132 gives us 18. Then we divide by the 3, and this will give us z is equal to 6. This will give us our first letter. In order to get another letter, we can look back at the top of this page and notice that we have two equations that link z to x. We can use either one of those equations to move forward. In general, it's better to use the simpler of the two to prevent yourself from making any minor math errors. So we will let z equal 6, and we'll use line 2 this time. It appears that the numbers here are a little easier to work with. We will say 4x minus 5z equals negative 10, but we'll now throw that z of 6 in the position I'm pointing to in orange. We'll now have 4x minus 5 times 6 equals negative 10. Negative 5 times 6 would give us negative 30. Then we can take the 30 and move it to the other side. When we move that negative 30, it will become positive 30. Now we have only 4x on the left, and then negative 10 plus 30 would give us 20. And then when we divide by 4, we will get x equals 5. Now we have two letters, z equals 6 and x equals 5. The only letter we don't know is y. However, recall the first slide that we did. We wrote an expression for y at the very beginning that depends on x and z, which I'm boxing in orange now. Y is equal to negative 4 minus 5x plus 4z. But now we know x and we know z based on our work we just did. We will use the x and the z we found along with this expression that we wrote all the way back at the beginning to solve y. Here I've written down our expression for y that we wrote at the beginning of the problem along with the z and the x we solved for. Now we will take the z and place it into the z position in this equation. We'll do the same thing for x also. The 5 will go wherever we see x. Now, let's rewrite the expression with the x and the z substituted in. When we place those numbers in, we can simplify, and we'll get y equals negative 4. Negative 5 times 5 gives negative 25, and 4 times 6 gives positive 24. When we combine negative 4 and negative 25, we will get negative 29 plus 24, and therefore our y is equal to negative 5. When we write our answer, we'll put triangular brackets, and we'll put x, y, and z in order. So we'll have 5, comma, negative 5, comma, 6. Always write x, then y, then z when you're writing your solution. So once again, at the end of a problem with 3 variables, we'll have to go back to the beginning in order to get y.